13 hours. That's how long it took for someone to weaponize CVE 2026-33626 after it was publicly disclosed. Not days, not a patch cycle. 13 hours, and active exploitation was already confirmed in the wild. Let's talk about what this actually is, why the attack surface is larger than most teams are treating it, and what you need to do before the end of your next on-call shift. LMDeploy is an open-source toolkit from Shanghai AI Lab. If you're running LLMs in production and you're not using the big commercial APIs, if you're self-hosting Llama variants, Qwen, InternLM, or anything in that ecosystem, LMDeploy is a legitimate and widely used option. It handles quantization, model serving, and inference throughput optimization. It's not a toy project. It has real production deployments, and that's precisely why this matters. The vulnerability itself is a server-side request forgery flaw, CVSS 7.5, which puts it in the high-severity bracket. SSRF, for anyone who needs the refresher. It's a class of vulnerability where an attacker can coerce the server into making HTTP requests on their behalf, to internal services, to cloud metadata endpoints, to anything the server can reach that the attacker normally can't. The server becomes a proxy for lateral movement or credential harvesting. Now here's where the inference infrastructure angle gets specific and uncomfortable. When you deploy an LLM serving stack, you're typically running it inside a cloud environment, AWS, GCP, Azure, or a private Kubernetes cluster. That environment almost always has a metadata service endpoint. On AWS, it's the IMSF1 or IMSF2 endpoint at 169, 254, 169, 254. On GCP, it's metadata. Google, internal. These endpoints hand out IAM credentials, service account tokens, and instance configuration to anything that can reach them from inside the instance. That's by design, for legitimate processes. An SSRF vulnerability turns that design into a direct credential exfiltration path. If your LMDeploy instance is reachable from the internet, or even from a broader internal network segment than it should be, an attacker who hits this CVE can potentially walk out with cloud credentials. From there, depending on what IAM permissions are attached to that instance role, and in practice, those permissions are frequently over-provisioned, you're looking at a potential pivot into S3 buckets, into other compute, into whatever that role can touch. The 13-hour exploitation timeline is worth sitting with for a moment. This is not unusual anymore for high-profile open-source infrastructure tooling, but it is a signal about who is watching these disclosure feeds. Automated scanners are indexing CVE disclosures and cross-referencing them with Schaden-style internet exposure data. The time between CVE published and exploit attempt in the wild has been compressing for years. For anything with a public-facing endpoint, your patch window is now measured in hours, not days. If your operational posture assumes you have a week to respond to a high-severity CVE, that assumption is broken. On the specifics of this particular vulnerability, the full technical write-up was not complete in the reporting available at time of writing. The Hacker News piece is largely a repackage of the disclosure notice, which is worth flagging. Unclear from the reporting exactly which API endpoint or request handling path is the vulnerable surface, what the exact payload looks like, or whether authentication bypasses are required, or if the SSRF is pre-auth. Pre-auth SSRF is considerably worse. That distinction matters for your triage, and you should check the official LMDeploy GitHub advisory and the NVD entry for CVE 2026-33626 directly rather than relying on press coverage for the technical specifics. What is clear? There is a patched version. If you're running LMDeploy, your first action is to check your deployed version against the fixed release. The patch should be in the LMDeploy GitHub repository. Check the releases page and the security advisories section. Update immediately. This is not a schedule it for next sprint situation given the confirmed active exploitation. While you're doing that, let's talk about the broader threat model, because patching this specific CVE is the minimum, not the complete response. Inference infrastructure has a security hygiene problem that predates this CVE and will outlast it. When teams stand up model serving endpoints, the security review tends to focus on the model itself, data privacy, output filtering, prompt injection. The underlying serving stack gets treated more like internal tooling than like a public-facing web service. But if that serving endpoint is reachable, even internally, and it has a vulnerability. The blast radius is determined by what the host instance can reach, not by what the model does. A few concrete things to check in your environment right now. First, is your LMDeploy endpoint, or any inference serving endpoint, directly internet accessible? It probably shouldn't be. If it is, put it behind an authenticated reverse proxy or an API gateway with rate limiting and auth enforcement. The model serving layer is not designed to be a hardened public endpoint. Second, what IAM role or service account is attached to the instance or pod running your inference server? Pull up that role and audit its permissions. If it has broad S3 access, or permissions to describe EC2 instances, or anything that goes beyond what the serving process actually needs to function, scope it down. The principle of least privilege is not new advice, but inference workloads are new enough that they frequently escape the IAM hygiene reviews that more established services went through. Third, if you're running on AWS and you haven't enforced IMS2 on your inference instances, do that now. IMS2 requires a put request to get a session token before you can query the metadata service, which adds a layer of friction that breaks naive SSRF to credential theft chains. It's not a complete mitigation for SSRF, but it raises the bar. GCP has similar controls around metadata endpoint access that are worth reviewing. Fourth, network segmentation. Your inference servers should not have unfiltered egress to arbitrary internal services. If the process legitimately only needs to talk to a model registry and an object store, firewall everything else. Egress filtering on inference workloads is almost never in place because people think of them as consumers, not as potential attackers. An SSRF vulnerability flips that assumption. Fifth, look at your monitoring. Do you have logs on outbound HTTP requests from your inference serving processes? Probably not, because why would a model server be making outbound HTTP requests under normal operation? That means SSRF exploitation may be invisible in your current observability setup. Add egress logging. It's cheap, and the signal-to-noise ratio for unexpected outbound calls from an inference server is very high. The broader pattern here is that the LLM deployment tooling ecosystem is young, it's moving fast, and it's being adopted in production environments that have mature security requirements. The tooling has not caught up. LMDeploy is not uniquely bad. This is a general condition. LLM, TGI, Triton Inference Server, Llama in its various deployment configurations. These are all serving infrastructure that needs to be treated with the same security rigor as any other public or semi-public service. CVE 2026-33626 is a reminder that the attackers are not waiting for the ecosystem to mature. The real takeaway here is operational. Patch LMDeploy to the fixed version today, then spend an hour auditing the network exposure and IAM permissions of every inference serving process in your infrastructure. If you can't answer, what can this instance reach? And with what credentials, in under 5 minutes, that's the gap to close.